MCP. MCP stands for Model Context Protocol. But what is it, why it is needed, and how to use it? By the end of this video, you will get the answers to all of your queries. Let's try to understand it with an analogy. Imagine you have a garden and want to do the landscaping. If you seek a general helper, you need to explain him which tools to use and give detailed step-by-step instructions to perform the task. Whereas if you get a professional gardener, you just give him a high-level instruction and he will do all the tasks himself by selecting the right tools. So which option will you choose? Of course, the option of the gardener. Now, we can consider MCP as the professional gardener who knows the tools and how to use them. The option 1 was like an API, wherein you give the detailed instructions on the methods of procedure. Now let's see why MCP is needed. Let's see a technical example. Imagine that you want to automate a task of creating files, reading files in your PC. If you ask LLM to do it, the LLM would respond that it does not have access to the file system. So how can you connect the LLM to the file system? Here we can use MCP. We simply configure a file system MCP server with a configuration file, and that's it. It's done. Now, if you ask the LLM to perform the following tasks, for example, can you write a poem and save it to my desktop? LLM will compose a poem and create a new text file on your desktop. If you ask, what work-related files are in my downloads folder? The LLM will scan your downloads and identify work-related documents. And if you ask, please organize all images on my desktop into a new folder called Images, LLM will create a folder and move image files into it. So now see the structure of MCP. There are 3 components to MCP: the MCP host, MCP client, and MCP server. MCP host is the user-facing AI interface, for example Claude app or IDE plugin, etc., that connects to the multiple MCP servers. MCP client, it's an intermediary node that manages secure connections between host and servers, with one client per server for isolation. The client is in the host application. Now let's see the core client features. In addition to making use of context provided by servers, clients may provide several features to servers. These client features allow server authors to build richer interactions. These features are sampling, routes, and elicitation. Sampling allows servers to request LLM completions through the client, enabling an agentic workflow. This approach puts the client in complete control of user permissions and security measures. Example, a server for booking travel may send a list of flights to an LLM and request that LLM pick the best flight for the user. So in this case, the server is waiting for the handshaking signal from the user. The second feature is routes. Routes allow clients to specify which files servers can access, guiding them to relevant directories while maintaining security boundaries. Example, a server for booking travel may be given access to specific directory from which it can read a user's calendar. And the last feature in the client is the elicitation. Elicitation enables servers to request specific information from users during interactions, providing a structured way for servers to gather information on demand. Example, a server booking travel may ask for the user's preferences on airplane seats, room type, or their contact number to finalize a booking. Now let's check the features of MCP server. Core server features. Servers provide functionality through 3 building blocks. First is the tools, functions that your LLM can actively call and decides when to use them based on user requests. Tools can write to databases, call external APIs, modify files, or trigger other logic. Example, search flights, send messages, create calendar events. It is controlled by model. Now, the second feature is the resources. Passive data sources that provide read-only access to information for context, such as file contents, database schemas, or API documentation. Example, retrieve documents, access knowledge bases, read calendars. It is controlled by application. And the third feature is prompts. Prompts pre-built instruction templates that tell the model to work with specific tools and resources. Example, plan a vacation, summarize my meetings, draft an email. It is controlled by user. Let's put all this together with an example. Let's say a user wants to plan a vacation to Barcelona. Consider a personalized AI travel planner application with 3 connected servers. The real power of MCP emerges when multiple servers work together, combining their specialized capabilities through a unified interface. So we'll be using travel server, which handles flights, hotels, itineraries, the weather server, which provides climate data and forecast, and the calendar as well as email server, which manages schedules and communications. So the complete flow is as follows. User invokes a prompt with parameters specifying the plan vacation, the destination is Barcelona, the departure date and the return date, as well as the budget. Users select resources to include such as the calendar and travel server. AI processes the request using tools. The AI first reads all selected resources to gather context, identifying available dates from the calendar, learning preferred airlines and the hotel types from travel preferences, and discovering previously enjoyed locations from past trips. Using this context, the AI then executes a series of tools like search flights, which queries airlines for NYC to Barcelona flights. Check weather. It retrieves climate forecasts for travel dates. The AI then uses this information to create the booking and following steps, requesting approval from the user where necessary, like book hotel, which finds hotels within the specified budget, create calendar event, adds the trip to the user's calendar, and send email, sends confirmation with trip details. So the result, through multiple MCP servers, the user researched and booked a Barcelona trip tailored to their schedule. The plan a vacation prompt guided the AI to combine resources like calendar availability and travel history with tools such as searching flights, booking hotels, and updating calendars across different servers, gathering context and executing the booking. A task that could have taken hours was completed in minutes using MCP. Now let's take another example to see how MCP works. At its core, the Model Context Protocol allows an LLM to request help from external tools to answer a query or complete a task. Imagine you ask an AI assistant, find the latest sales report in our database and email it to my manager. Here is a simplified look at how MCP would handle this. First, request and tool delivery. The LLM understands it cannot access a database or send emails on its own. It uses MCP client to research for available tools, where it finds 2 relevant tools registered on MCP servers, a database query tool and an email sender tool. Second step is tool invocation. The LLM generates a structured request to use these tools. First, it calls the database query tool, specifying the report name. The MCP client then sends this request to the appropriate MCP server. Third, external action and data return. The MCP server receives the request, translates it into a secure SQL query for the company's database, and retrieves the sales report. It then formats this data and sends it back to the LLM. Now the fourth step. Now equipped with the report data, the LLM calls the email sender tool, providing the manager's email address and the report content. After the email is sent, the MCP server confirms the action was completed. And the final step is the confirmation. The LLM provides a final response to you. I have found the latest sales report and emailed it to your manager. If you think that this video has added some value, then please share it and also consider to subscribe to stay in the loop. If you have any other feedback, feel free to put them in the comment section. Thank you.